Hello, everyone. Um, as Eric mentioned, we're going to focus on charm debugging, and well, debugging can be useful in many situations. Like either you have a charm and that's broken, there's a CI that's telling you there's a problem, or you're just starting to build a charm, so you're developing it, you're adding a feature, you're changing something, you're poking around. Um, Now, this presentation is going to, well, like I'm assuming you're all familiar with, Juju status, Juju debug log, Juju models. Let's say with the Juju CLI, maybe some of the more, say, obscure or let's say low-level Juju commands such as Juju SSH, that one you probably heard of. Debug hooks and debug code. We're going to be looking into those. But more in particular, I'm going to focus on jhack, which is a command line tool that I wrote and that I maintain. It's it was born as a collection of scripts. As I was developing charms, I realized that there was a need for some developer and debugging tools. And so I just started, putting together a bunch of scripts, Python scripts, and then they grew and it became a collection of scripts. And then people who were interested, so I started, I put it in a snap package. It's a strictly confined snap, so the only damage it can do really is to your Juju. So please be careful with production environments because some of these commands are quite destructive. In the edge channel, there are a few more protected, like a few more protections added to jhack. So, for example, jhack nuke, which, as it quite candidly declares, is a surgical carpet bombing tool. So it's just it's for destroying stuff really, really quickly. So again, careful in your development or in your production environments. So yeah, given that disclaimer, second disclaimer, I 99% of the time work on Kubernetes models. So I work with Juju on Kubernetes. So it may well be like I often find that there's bugs in jhack when it comes to using it on machine models because I don't have myself much experience developing on machine models, and because most of the people that are using jhack so far are on Kubernetes. That said, I wrote jhack with like the goal in mind of it being substrate agnostic or portable. So if something does not work on machines, I do want to know, and I'm going to fix it as fast as I can. So if you find something, oh, that should work, please report it on GitHub so that I can fix it. Or just help me. Of course, PRs are always welcome. Given these two disclaimers, yeah, so I'm going to be, I'm running here Juju on microK8s. I have a local microK8s cloud, and I have deployed a couple of units of Prometheus and 1 unit of traffic, all from Edge, from Charm Hub. Then, yeah, here I have Juju debug log and Juju models. Let's take a quick look at jhack. Jhack is a bunch of commands. Some of these are subcommands. So, for example, if you do jhack charm, that should show you some subcommands. So jhack charm is like a container for more subcommands. Okay, so the ones we're going to be looking at today are, I would say, the most interesting ones, or the most, say, useful for beginners, are probably show relation, sync, tail, Nuke I use a lot because I have a ton of development models and development things that I need to constantly clean up. And jhack Fire is also, and Replay, that if we have time, we're going to get to those as well. So let's start by looking at tail. So what does jhack tail do? Jhack tail essentially scrapes the debug log for log messages concerning events being fired by Juju on your units. So it's essentially like a very stripped down debug log where only the events are shown, which is useful for when you're debugging relations. So for example, if I were to do, if I were to nuke the ingress per unit relation in traffic, there we would see Prometheus 0 and 1 receiving ingress relation departed events, traffic 0 showing some ingress per unit departed and removed events. Now Prometheus goes in error state because that's Prometheus. That's my team's fault, not mine. And you can filter stuff. So you can sharpen the tail and say, I only want to tail traffic 0. Let's remove Prometheus because work. And let's deploy it again. And oh, yeah, wait, let me show something else. Let's wait for Prometheus to come up. We're in maintenance. Okay, that means we're good already. Config change failed. Oh, yeah, I know what that is. Yeah, that's the container. That's a known bug. But let's quickly look at iMatrix. iMatrix is a command that I wrote because often, well, in this case, it's maybe not that useful, but often when you're just trying out charms, you deploy a bunch of charms in your model, and then it's not obviously clear how they can relate to one another, what commands are needed to relate them. It's quite verbose every time to go and Juju relate X and then the endpoint name and then the other charm and the other endpoint. And I also wanted to be able to see at a glance like the graph. So who's provider, who's requirer, what's the interface. So I wrote this simple command to scrape the integration matrix, that's what iMatrix stands for, off of the current model and display it. And there's also a fill command, which essentially is going to cross-relate everything. So now the model is fully connected. And you can see stuff happening in Juju, and you can see the tail showing the new events coming in. The benefit of the iMatrix becomes more relevant when you have models with more units, more things, more apps. So for example, I'm going to deploy cos light. And there's a test model there.
And cos light is the lightweight monitoring stack, right, Pietro?
Yes, yeah, sorry. COS is like I work in I'm in Canonical in the observability team, and yeah, I'm deploying COS Lite because I know that it's a bundle that's relatively stable. There's a bunch of charms in there. We went general availability, I think, in November or December, last year. So you can, yeah, that's the observability stack, canonical observability stack light. So there's Alert Manager, Catalog, Grafana, Loki, Prometheus, and Traffic. And Traffic is the charm that I know best because that's the one that I've been developing the most in my time here. So just to show you a bit of a more interesting use case for iMatrix, while that deploys, I'm going to move back to my previous model so I can keep talking to you about Tail. There's a few niceties in Tail. So if you don't know that, you can configure Juju's Juju model's logging level. And for jhack Tail to do more of its advanced jhack magic, you're going to need the debug level on units. So if you set your model config logging config unit debug, then you're going to be able to see what I'm going to see in a moment. RLN. So what I'm going to do now is, okay, maybe let's take a step back for this one. Let's take a quick glance at the Juju charm runtime. There is a controller, a Juju controller, somewhere deployed in your cloud. We're on Kubernetes, so there is a sidecar and there is a workload container. If you're on a machine, that's one thing, and there is no Pebble, but the same concepts for the rest apply. Here is my charm. So this is my Python process executing that charm.py file. That happens via a function, via let's say a script, shell script called dispatch, which is on the unit. So just say, I don't know, let's take a look at traffic. Here's the dispatch script. This is a very tiny Python script. All that it does is it executes the charm with a Juju dispatch path, which is essentially what's telling the charm what event is being run right now, and the specific, and the environment with which dispatch itself is being run by the Juju agent, which is not in the picture, but it's essentially a mediator between the controller and the charm. Then the charm executes, and using the so-called hook tools, it is going to access Juju model data, again, through the controller. The command that I'm about to show you essentially allows you, as a developer and debugger, to execute the charm without Juju being behind it, let's say. So it's not Juju triggering a charm execution by executing an event. It's you executing the charm and simulating the dispatch call that would otherwise have been normally executed by Juju. So you all know that there is an update status event. If you type jhack fast forward, it is going to temporarily set the update status hook interval to essentially speed up the update status execution rate. You know that the default is at 5 minutes, but I want it to occur every 5 seconds, because sometimes during development you want things to move a bit faster. You want the traffic or the charm you're developing to update a bit faster. So this is one way in which you can do it. Now I just reset it back to normal. So you could see that these update status events are show up in tail. That's the only thing I wanted to show. Now, let's fire an update status event. This is how it shows up in jhack tail. Now you see it's different. That's to signal you that this event has been fired by jhack. And how do we know that? We know that because we've logged a message. So Juju log receives a log line that says the previous update status was fired by jhack. So the tail picks up on that message and updates the previous event to signal, hey, this was fired by jhack. It's not a real Juju event. This is you messing around with the charm environment and executing it, pretending to be Juju, let's say. All right, so we can do this over and over, right? So we can simulate events, and that's not just update status. We can simulate an ingress variant relation change event, for example, which is a complex event, right? So it typically occurs when Prometheus, in this case, has touched its data bags. So suppose that you're debugging a hook that handles that event. In order to test it, to stress test it in a live environment, you would have to every time unrelate traffic and Prometheus, re-relate them, and wait for the right event to fire. While in this case, you can just trigger it manually, and it's going to execute at will, which is very nice. Now, before I show you how you can use this in together with some more advanced jhack tools, I'm gonna show you how you, let's say, the standard or built-in way to do charm debugging in Juju. And that's there's two ways to do that. The first of all is the first one is debug hooks, which is yeah. What's that? All right. So debug hooks is going to essentially SSH you into the Juju unit and sit at this level. So just before dispatch fires. So it's going to inject. It's going to insert like a breakpoint in the charm control flow about here, and it's going to wait for an event to fire. So it's going to wait for Juju to execute an event on the charm. So, for example, let's trigger one, update status. So we don't have to wait 5 minutes for it to happen. We have received an update status. So the debug hooks session has started. So we are now in a tmux session. We are in the charm container on the charm unit, on the traffic unit. So we can just, we are in the charm root, and we can, most importantly, run dispatch. So as you see, when I run dispatch, it is going to output all of the debug logs that would normally be output when you run update status. So it is really executing the charm. And nice thing about this is that you can do this over and over. You can fire dispatch anytime you like. So if you manage to put a breakpoint by debug hooks on the right event, the one that you're developing, the one that you're debugging, then you can fire it over and over. You can go and change the code by installing Vim and going and hack on the charm file. You can insert IPDB breakpoint in there. Let's do that. Okay, but first the point is using this debug hooks is going to put you in a position where you can test and execute a charm multiple times under the same conditions, which is very useful. Now let's open the charm that I'm developing. So in this case, we're in traffic. That's the name. All right. So this is my charm root, and this is my charm source code, which is my traffic ingress charm. Okay, now suppose that you want to enter a PDB session in the charm code, and you want to, you would like to, have in this schematic session now enter a PDB session so that you can step through the code and see what's happening in the charm. Well, you can do that the good old way by apt installing Vim or Emacs or whatever your flavor is, and then go and edit the charm file, because the charm file is by that's there. Or you can do it the jhack way, which is simply to run jhack sync. Jhack sync and then traffic 0. You can also omit the unit, and then it's going to sync it to sync the local charm sources to all traffic units. So if you have multiple units, this is handy. Now it's going to tell you exactly what it's watching. So sync is a command that is going to basically scan the local charm tree, collect by default all Python files you can find, and then sync them with a live unit. So whenever it listens to changes, so whenever you change something here, it's going to sync it to traffic 0. So let's use that. Let's enter a PDB breakpoint. And now let's run this batch. Oh, set trace takes 0 positional element. Oh, yeah, maybe it was what's it called? Title? Header. Yes. There we go. We are in the PDB session. So self is charm, self unit name, whatever, right? So we are now in the PDB section. We can you can do whatever you like. Of course, you can put such a breakpoint in your event handlers. You can do more advanced, like you don't need to put it in it. You can do whatever you like.
Pietro, from the last workshop, this didn't work for LexD. Did you fix that bug? You remember that it didn't work for LexD?
I don't remember what didn't work for LexD, and I didn't see a bug report on GitHub, so I didn't take it. No.
Oh, the sync command. I think it didn't work.
Sync.
Yes, I think sync was the command that actually didn't work. Not sure.
Yes. Okay. Oh, yeah. Now I remember. So there is a subtlety with sync. So jhack, at least the version that's live right now, cannot distinguish between machine and non-machine models. So you need to pass a flag to tell to jhack this is a machine charm, because the location to the charm root is different between machine units and between machine units and Kubernetes units. So you should try with the machine flag, and if not, there is a pull request open where I add a get substrate helper that is able to determine if the current model is machine or K8s, and so that should fix that issue, and it should essentially skip. It should prevent you from needing to pass a flag whether the charm is a machine charm or not. So that should disappear soon, but for now, if you're using Edge or any of the published snaps, actually, you're going to need to specify if you're trying to sync into a machine charm. Any other questions on this? All right. The second itself. The second built-in debugging tool, which nota bene is only going to work on ops charms, so on charms written with the operator framework. So it's not going to work on bash charms or Rust charms or whatever other types of charms there are, is debug code. The principle is similar in that because so the principle is similar. So it's going to set up a listener. Only the listener is not sitting there before dispatch. The listener is sitting in the charm, and it's already a PDB listener. So let's give you an example. Let's fire an update status. There we are. So where are we? We are in the onUpdate status event handler. We are in here. What happened is that the operator framework has listened to, like, has put a breakpoint for you on the first event handler that's hitting the charm. So we are receiving an update status event. Therefore, we enter the debugging session at the just at the first line of the event handler that you're specifying. So if I were to do debug code ingress per unit relation changed, that would sit there a while, because to obtain an ingress per unit relation changed, I would have to unrelate Prometheus and traffic, or just wait for it to trigger, wait for that specific event to trigger. Questions on that? Otherwise, I'm going to move to, well, what else did I want to show? Oh, yeah, show relation. That's interesting. No questions? Right. Let's look at show relation. Show relation is a very useful command if you are developing or debugging integrations, as they're called nowadays, between charms. So the traditional way to look at relation data is to type Juju show unit. Juju show unit traffic 0 would show you the contents of the data bags of the applications it relates to. So it would show you not the contents of traffic's data bags, or at least, like, it depends a bit on how you conceptualize the thing, but I find it easier to think of a data bag as a shared database with two buckets. One that sits on the side of the provider of the relation, and one that sits on the side that is owned by the requirer side of the relation. And when I type Juju show unit provider, because in this case traffic is the provider of this relation, I actually see the data bags of the requirer. So I wrote show relation to be able to see at once both sides of the relation, So it's essentially a command that shows you as a snapshot of the data bag from both sides, all buckets. So it's like a full picture of the relation data that two applications are sharing. Yeah, like most of my commands try to minimize the amount of typing. So you can type endpoint 1, endpoint 2. So you can do show relation, traffic, ingress per unit, and so on. Or you can just count essentially, yeah, let's see, it's not really an ID, it's just the number, say, okay, the row number that the relation occurs in here. So in this case, I'm interested.
Can you also, like, so as an example, show the Juju info relation, even though it's a hidden one?
Oh, I'm actually not sure. Let's we can try that. But before we do that, I'm going to show you the ingress per unit. And I'm going to put it on a watch. So this command keeps updating the relation data visualizer in the background as it changes. So if we do Juju config traffic and then external host name, yeah, you can see I've done this in Prague. I changed the external host name to hello folks. You should quickly see this one change. Hopefully. Or is it still foo.com? Yeah, hello folks. I'm not sure why it was not updating, but I don't know. I'll have to look at that. But yeah, so you can see now that the URL of the ingress provided by traffic has changed to the new value. So you can see at a glance what's in the relation data for ingress per unit. Now, you said, let's see at the Juju info. Is it visible in here? Ingress per unit, metrics endpoint. So the answer is I don't think it can show it because it can only see what Juju show unit sees, in fact.
Yeah, totally. And you don't have a subordinate or anything, so that's why,
no.
maybe. Yeah.
So no, I can show the metrics endpoint relation. I can show the ingress relation, Prometheus peers, even peer relations. I show peer relation database nicely, but no, not handle hidden relations.
So show relation is effectively only using a show unit in the backend, right?
Yes. So it's collapsing the show unit. Well, actually, it's running Juju show unit for all units for both applications and showing that in one view. Yeah.
Okay. So actually, because I'm thinking is that it's really cool for debugging in operations, not development, because it's probably going to work on any sort of old reactive legacy charm as well.
You're right. I think yes. Yeah. Like, so maybe something I didn't mention. Like, some of these commands only work with operator framework charms. Some others should work on any. Yes, some others should definitely work on any type of charm. And some commands are dangerous, so please do not use them in production. Or if you do, don't blame me. But some others are just data gathering and formatting, pretty printers, nothing more than that. So those are perfectly fine to use, and show relation is one of them. Also, another cool one, if you're looking at debugging real life charms, is show stored. show stored is very similar to show relation. Only it shows the storage. So you know that charms can use stored state, in order to, to have to attach some state to themselves, put it in a, I think, SQLite, or I don't know, some sort of in-memory file database in the unit itself. And this command allows you to inspect the contents of that data. So if I show the stored data of traffic 0, what I'm going to see is that it has 2 instances of stored data. One of them is on the ingress charm, on the charm itself. So the nice thing is that this gives you exactly the address of the object. So you see that, and you know that we're looking at this guy. So we're in traffic ingress charm dot underscore stored. So that's the thing we're looking at. And here, this other show stored, this other stored data instance, we're looking at the traffic route provider, which is this guy. So it gives you exactly the address of the stored state instance that you're looking at. It also tells you what type it is, and if it's a dict, it's going to print it for you, but otherwise not. You can add custom printers and stuff, but it is only going to serialize the data if it's a dict, because stored state is going to be pickled and unpickled for you at the operator framework level. So I cannot just guess what data type it is to print it. If it's a dict, I'm going to do it. Otherwise, I'm just going to dump the raw contents. So it's going to use the Python representation, whatever that is.
The show stored is only for operator framework charms.
Yes. Definitely, yes, stored state is an operator framework construct. Yes.
Yeah, sorry if I insist. Just production overwhelmingly runs on non-operator framework charms for now.
Right. Well, there is the thing that if your charm is using controller storage, so like if say you have a bash charm that as storage uses a txt file stored on the unit itself, then there's nothing I can do about that.
Sure.
But if it's using controller storage, like Juju set state, Juju get state.
I was actually thinking about the UnitDB SQLite databases for a lot of the old charms.
Then it might just work, because so long as the location of the database and its formatting are what I expect them to be, so compatible with what the operator framework does, then it should work.
I'll try. I don't know if the two formats are compatible.
Give it a try.
Yeah.
Give it a try. But if the charm is using operator, if the charm is using controller storage, so you know that you can call main. You can call main with use Juju for storage true. You shouldn't typically do that, but a lot of people do. In that case, you can pass this controller storage flag, and it's going to get the storage from Juju instead of trying to look for it in the database, in the local database. So if your charm uses set state, get state, you should be using controller storage, and it should work. All right, we have 10 minutes to go, and I think I talked you through about the. Oh yeah, let me show quickly iMatrix, because that one is cool. So we are now in the COTS model. So we have a bunch more units, and they're all related to one another. Sure. So this is the integration matrix. It shows you like the alert manager is provider for Grafana with the Grafana dashboard, Grafana data source interfaces. So this is about interfaces and not endpoints. So it's not concerned with how Grafana calls this relation. It's about what relation interfaces these charms are using to talk. Yes, so you can see that they're all green. I think I can put this on a watch. Yes. Yeah, this command is a bit slow because Juju is not very forthcoming when it comes to telling me what the relation interface is. Like it's easy. No, wait, that was not the reason. What was the reason? Yeah. Oh, yeah, that was the reason. So there is probably a bug in status that if you query the status to get the JSON version of the, so like if you do the status format JSON, it does not include the interface name. So in order to get the interface name, I actually have to SSH it out of the unit, which is crazy, but for now, that's what it is. So that's the reason why the command is a bit slow. But suppose that I do jhack nuke Grafana semicolon. What this command is going to do is it's going to disconnect Grafana from everything. So it's going to nuke all of the relations coming and going from Grafana. So what this should do is it should essentially turn red a whole cross of this table. It should shut completely down the Grafana column and the Grafana row, and you can see that happening live. And unless something went into error. Yeah, so something might refuse to disconnect because it errors out. But either way, what should happen is that the Grafana row and column both turn red. And iMatrix is really useful for stress testing this kind of cross-related models, where you have a bunch of charms related to one another, or you deploy a new charm and you just want to relate it to everything. Then you can use iMatrix. So what the fill command is going to do is it's going to relate everything that it can relate to one another. So essentially, it's going to flip every single one of these into green. And what clear is going to do is the opposite. It's going to unrelate everything. So destroy every single relation it can find. And that might take a little bit to process since it's a large model. But then if afterwards you do jhack iMatrix fill, it should do the reverse. So it should relate everything. But we're not going to wait for that to happen. Now, at this point, unless there is a specific question about some other command, or yeah, I realized I didn't talk a lot about fire and replay, which is really interesting, but the time is what it is. But I think I covered the basics. So if you would like to know something more about one of the commands that I mentioned, or charms in general, this is the time. Otherwise, I'm going to stop the presentation and we can have a few minutes of just free informal Q&A.